Having introduced the active and passive properties of muscle separately, I want to start putting them together and composing them to get a better understanding of how muscle actually functions. So I've drawn the force length curve here, and I'm going to sketch out the two force length relationships that we know about. One of them is the active force length curve for muscle. And let me just move this label out of the way here. Again, what we're plotting is the muscle fiber length relative to its optimal fiber length, which is defined as whatever the length of the muscle is that produces the most amount of force when it has a velocity of 0. So we'll just call this like 1.0. So whatever that amount is, that's 100% of the maximum force production capability, because that's how we define it. And as the muscle gets significantly shorter than that, its force production capabilities drop off. And likewise, as the muscle gets significantly longer, its force production capabilities also drop off. Until they get to certain little cutoffs here and here. These happen at about 50%, like I said earlier, about 50% and 150% of the whatever the optimal muscle fiber length is. And then before we talked about the active properties of muscle, we talked about the passive properties of muscle. So suppose you're not activating your muscle at all. As a function of how long the muscle is, meaning the length of the muscle fiber specifically, I don't mean the anatomical length of the muscle, but I mean relative to what its optimal fiber length is, what is the length of the muscle currently. You get no passive force when it's shorter, of course, just like you get no passive force with a rubber band when it's shorter than its, you could call it like its slack length. But after a certain point, you get that very classic nonlinear viscoelastic biological tissue force going up like this, just like we saw with tendons, just like we saw with ligaments. Same deal. So this is, let's label this passive, and we can label this active. So as you might guess, to get the total behavior of muscle, like how muscle would actually behave in the lab or inside your body, we have to add these two curves together, add the yellow and add the green curve together. Now, of course, they'll add together to the green curve for everything right up until about here, because the yellow curve is 0. But we'll start getting something like this. We could maybe call this combined. So the lesson here is that the mechanical behavior of muscle under contraction, meaning when it's activated, is predominantly a function of the active properties at these low to moderate muscle fiber lengths. But once the muscle starts getting stretched out, that's when you start seeing the contribution of the passive properties of muscle. So that's the actual intrinsic stiffness of the muscle stretching out and providing resistance as the muscle gets very, very long. So the combined force production capability of a muscle doesn't go to 0 when it's very long. Just the active component goes to 0. Something that's also worth maybe noting, and we'll talk more in detail about what modulates the precise shape of this, but if you could choose to operate somewhere on this curve, ideally operating in this region would be good because you get the maximum amount of force production, versus if you're forced to operate like way out here on the curve, then you're not getting very much force production because your muscle's too short, and likewise up here, the muscle's too long. So this is starting to put together the active and passive properties of muscle to get an understanding of how the muscle functions as a unit.